Right, so welcome to the second part of lesson 3.2. First objective was to solve systems by substitution. Second part is solve it by elimination. So that's what we're going to do here. Elimination is also sometimes called linear combination, because what you're going to do is you're going to add two equations together by simply adding the like terms. So 4x plus x is 5x. Negative 2y plus 2y is 0. The y's were eliminated. That's why it's called elimination. And then 7 plus 3 is 10. 5x is equal to 10. Now we're just going to solve for x. Divide both sides by 5, and you get x is equal to 2. Now, if you want to get the y value, which we do, we're going to take one of the equations. I'm going to take the second one because the numbers are smaller. And I'm going to substitute that 2 in for that x. Now just solve for y. So subtract 2 from both sides. You get 2y is equal to 1 divided by y is equal to 1/2. So the ordered pair solution here is 2 1/2. Very similar here. Add these two equations together. 3x plus 2x is 5x. Negative 2y plus 2y is 0, so they're gone. Plus 6 is 20. Divide both sides by 5 and you get x is equal to 4. Pick one of the equations, the second one, because it doesn't have subtraction and the numbers are smaller. It doesn't matter which one you pick. Same answer either way. I'm going to substitute 4 in for x there. And solve for y. You end up with 2y. When you divide by 2, you get y is equal to negative 1. All right, you end up with 4, negative 1. Let me know if you have any questions on that one. Take a look at the next one. It's a little different, right? Because if I just add these together, nothing will eliminate. But if you notice 4x and 4x are the same, so that's what I typically do. Some teachers or some books, if you look, will suggest subtracting. I think subtract leads to errors. So what I'm going to do is I'm going to multiply everything in here by negative 1 and rewrite it down here. So 4x times negative is negative 4x. 9y times 1 is negative 9y. 1 times negative 1 is negative 1. When we add down, 4x and negative 4x gone. 6y plus negative 9y, negative 3y. Negative 2 plus negative 1 is negative 3. Divide both sides by negative 3, and you get y is equal to 1. Then you just pick one of the original equations. I'm going to take the top one. 4x plus 9, y is equal to 1. We're going to substitute the 1 in for the y. So really it's just 4x plus 9. 9 times 1 is just 9. Equal to 1. We'll subtract 9 from both sides. 4x is equal to negative 8. Divide both sides by 4. And I get x is equal to negative 2. So my ordered pair here is negative 2, 1. Okay. Make sure the x comes first, even though we solved for the y first. So make sure your answer has the solutions in the right order. Last one here. Since the x's are opposites, we can just add them like we did for examples A and B. I don't need to do that extra step like I did for C. So when I add down, the x's are gone. Y plus negative 2y is negative y. Negative 9 plus 12 is 3. When I divide by negative 1, I get y is equal to negative 3. I'm going to take the top equation. I'm going to substitute negative 3 in for y. Plus a negative 3 is really like minus 3, right? So I'm going to have to add 3 to both sides to get that to gone. 3x is equal to negative 6. Divide both sides by 3. And I get x is equal to negative 2. So your solution is negative 2, negative 3. So now the question is, what do you do when there is nothing? If you just add down, that will eliminate, right? There is nothing. You can't just add these together like we could in the previous example. So those ones were nice the way they were set up, because all you had to do is add them together. It's not always going to be that case. So what you have to do is force it to happen. If you look back at this definition here, it says equivalent systems are systems that have the same solutions. So what we're going to do is create an equivalent system where I can just add them together. What does that mean? Well, you can create an equivalent system by doing operations to both sides of either of the equations. What I'm going to do is I'm going to multiply the first equation by 5 and the second equation by -3. The reason why I'm choosing those numbers is because 3 is the coefficient of x here, and 5 is the coefficient of x here. So I'm going to make them opposites. I'm going to make this one 15, and I'm going to make this one -15. Really, it's just multiplying by like the other equation's coefficient. And then I threw the negative sign in there so that they're opposites and they're not just identical. So here's what happens when I multiply across the first equation by 5. I get 15x plus 35y is equal to 75. Second equation, -3 times 5x is -15x. -3 times 2y is -6y. -3 times -4 is 12. This is an equivalent system to what we started with. They have the same solutions, so when I get the solutions for this one, it's the solutions to the original. So now I can just add the two equations together. The x's eliminate. 35y minus plus -6y is 29y. 75 plus 12 is 87. Now I'm just going to divide both sides by 29. And I get y is equal to 3. Now I'm going to go back and choose one of the original equations. I'm going to take the first one, so 3x plus 7y. Y we just discovered is 3. Now I'm going to solve for x. So 3x plus 21 equals 15. Subtract 21. 3x is equal to -6. Divide both sides by 3. And x is equal to -2. So you got -2, 3 as your solution there. We're going to do the same thing here. You don't have to just solve for the x. We could. We can also solve for the y. So I'm going to choose to solve this one by getting the y's to eliminate first, by just picking the opposite, multiplying by the opposite coefficients. So what I mean by that is I'm going to multiply this equation by the coefficient of the y down here, and I'm going to multiply the second equation by the coefficient of the y up here. I'm going to make this one negative just that way they end up being opposites. So multiplying 5 through by everything up here, I get 10x plus 20y is equal to -20. Multiplying through by -4 down here, I get -12x minus 20y is equal to 12. When I add down now, I get -2x. That's gone. And it's equal to -8. Divide both sides by -2. And I get x is equal to 4. Pick one of the original equations. I'm going to take the first one. So 2x, x is now 4, plus 4y is equal to -4. 8 plus 4y is equal to -4. Subtract 8, and you get 4y is equal to -12, and you get y is equal to -3. All right, so your ordered pair solution is 4, -3. So now the question is, what happens when, so if you recall back to last lesson, right, there's 3 different possibilities. You either get one solution, right, where the 2 lines intersect, and where they intersect is the solution. Or you could have parallel lines, which means there's no solution. Or you could have overlapping lines, which means there's infinite solutions. So far in this lesson, we've only looked at what happens when there's one solution. Well, algebraically, what happens when there's not? Well, let's take a look here. When I add these equations down, 2x plus negative 2x is 0, so that's gone. Negative y plus y is 0, so that's gone. So everything on the left side is 0. Both variables eliminated. On the right side of the equation, 3 plus negative 3 is also 0. So I got an equation that's just 0 equals 0. That means it's infinite solutions. Because what ended up happening was the variable's eliminated, and it's a true statement. Over here, so ultimately what would happen is these are the same line. If you were to graph these, they would be overlapping lines. Okay. Over here, 2x and negative 2x is 0. Negative 3y and 3y is 0. So that adds up to 0. 18 plus negative 6 is 12. That's not a true statement. So this is where it would be no solution. If you were to graph those lines, they would be parallel lines. They'd never touch. So that's why there's no solution. I believe there are 2 left, C and D. I'm going to leave those for you to do as an exit ticket. So again, if all the variables eliminate and it ends up being true, it's infinite. If all the variables eliminate and it's false, it's no solution. All right. Let me know if you have any questions. Try the exit ticket, and we'll start the practice tomorrow.